in part 1 we assembled this clamp mechanism and we fully constrained the parts. We want to animate the mechanical movements, but before we do so we need to modify some of the mates. So on these clamp sections I've added some guideline sketches. These sketches are actually in the individual parts. So let's have a look at the part. Here is my clamp part and here is my sketch. So let's just have a quick look. So I have a tooth profile and I want to track it. So I've aligned circles to the inner and outer section of the tooth profile, and then I've tracked the mid-plane. Now it's the middle circle that I'm interested in because I'm going to put together a rack and pinion mate. So the middle circle is 10 millimeters in diameter. Okay, and that's going to be really useful when we come to do the rack and pinion mate. So let's go back to our master model, or indeed our assembly model. Right, and I'd like to put together this rack and pinion mate, but before I do so I need to turn off one of my other existing mates. So as previously said, all the parts are fully constrained. I need to now deactivate one of these four constraints. So in the clamp hook I need to get rid of the parallel body mate. So this is just matching the cog to its hard stop position. I need to do this for both hooks. So let's turn the parallel mate off for the other hook. Okay, so now both are movable. So let's replace this with a rack and pinion mate. So we're going into mechanical mates. We're going to rack and pinion. And we need to select a rack and a pinion. So for the rack, I'm just going to pick this line, this edge from my rack. And now for the gear, it's very important that I select that middle circle, that 10 millimeter diameter circle, because the tooth profile from both parts are matched together, and it's this circle that guides the pitch. So let's accept this. I need to do it again for the other side. I'm unsure at the moment whether I need to select the same line, but for trial and error purposes I'm just going to select the opposite, and then I'm going to select the same circle. Now this may or may not work when we come to animate it later on. We'll find out, but we can easily trial it and then modify the mate if it doesn't quite work out. Okay, so I now need to have a look at my front plane. So I constrained to the front plane before. I constrained my body to the front plane. So if I split, do a section view by the front plane, I can see that it intersects perfectly through the diameter of the handle. And I did this on purpose because I now want to create a spring on this plane. And this is going to be an interactive spring that works within this assembly. So I don't want to start a sketch. What I want to do is I want to insert a new part. So let's go Assembly, Insert Components, New Part, and a part will have appeared. See Part 1. Let's rename it Spring. Okay. And now I want to edit this part because I want to add some function to it. So I'm going to draw on the front plane within the assembly. Let's bring up an axis to work with. And so I'm actually, what I'm doing here is I'm modeling my part, which I would usually do externally, in the actual assembly file. And that's because there's geometry that I want to track in the assembly file. So let's just add some constraints for a sketch. I'm going to basically put together the profile for the spring. So this is going to be the start point for the spring. it'll become a little clearer pretty soon why I'm mapping it out like this. Okay, so that's going to be my wire diameter, and now I need to wrap it around an axis, and unfortunately I need to draw an axis in another sketch. So back on the front plane, I'm going to sketch again, and I'm going to match to this axis. That's where I want it to be, and I want to fully constrain it to the base, which is the start point of the spring. And I don't quite want to match it to the end point of the spring up here, but I'm going to anyway, just to show you what happens to the spring if I do match it to that line. Basically what I actually want is I'm going to offset it, but it doesn't make sense at the moment. Okay, right, so let's go into features. We've got our two sketches. Okay, so there's the two sketches. So let's go features, and we're going to go swept boss base. Then we need to select a profile and a path, and we've just drawn both of these. So here's our profile, and the secondary sketch, here's our path. Now I want to travel the length of the path, so I need to modify. It's probably not path alignment minimum twist, it's going to be follow the path. I need to change this, and I need to twist along the path. So I'm going to travel up the path, but I'm going to twist, and my spring is going to have 5 turns, so 360 degrees times 5 is going to give me 5 full turns. So I've twisted along the path, and this creates my makeshift spring. But this isn't quite right at the moment. As you can see, it intersects, it goes straight through a solid body. We don't want to do this, so we can change the line that we drew earlier for our center line for our path. So let's modify this, and let's offset the top of the line by the diameter of the wire. So let's delete this mate, bring it down. So the dimension is going to be the diameter of the wire, which is 1 millimeter. And then when we say OK, everything should match up. So here's my spring, my makeshift spring. Now, the spring, because it's modeled in Solidworks in the assembly and it's constrained to the assembly, it should move with the assembly. So when we go into animate, we should find that the spring does move exactly as we want it to. And this, let's just save this before we finish. It sets us up nicely to now go into our motion study. The spring is going to be saved internal. We're going to leave it internal. And in the next video, we'll look at how to animate.